Hey class, this video is going to talk about conditions for parallelograms, which is kind of similar to the properties that we've already looked at in section 6.2, but basically the main difference is we have a quadrilateral, we're not sure if it's a parallelogram. If these conditions are true, the ones that are listed here, then we have enough information to say that it's a parallelogram. So you can find these conditions in 6.3 in your book. It'd probably be helpful if you make sure you have that before watching the video, but I will kind of briefly go through those. So if we have a quadrilateral, which remember means a four-sided figure, and I know that one pair of my sides happens to be both parallel and congruent, then my quadrilateral is a parallelogram. So you can see that the condition is finished here. So if this is true, that's enough to say it's a parallelogram. Okay? Second condition, if both pairs of opposite sides are congruent, like shown in this picture, that is also enough to say that ABCD is a parallelogram. If I have a quadrilateral and my opposite angles are congruent, and this one has to be both pairs, if both pairs are congruent, then it's a parallelogram. That's enough to determine that. Fourth condition, if both pairs of consecutive angles are supplementary, then it's congruent. So if I just were to have A and D be supplementary, that's not enough information. I would also need the other consecutive angle to be supplementary. If both are supplementary, then I can say that this is a parallelogram. And then last one, if the diagonals bisect each other, that's enough to say it's a parallelogram. So as you can see, a lot of them are very similar to the to the properties. The main one that's different is this first one. But the rest are just the properties that we learned. If you can find the properties happening, your quadrilateral must be a parallelogram. Okay, so we want to determine, in this example, is this a parallelogram if x equals 7 and y equals 4? So they're giving me the opposite sides. So remember, one of the conditions is if my opposite sides are congruent, both pairs, that's enough to say it's a parallelogram. So I need to make sure BC is congruent to AD and AB is congruent to CD. So we're just going to plug in our values. So BC is 7 plus 14, which is 21. So I'm plugging in 7 for x. I'm going to do the same thing down here. AD is 3 times 7, which is also 21. So BC is congruent to AD. Okay, so there's one pair of congruent sides. Now let's see if we can show the opposite pair. So now we're plugging in y, so y is 4. So BA equals 5 times 4. Sorry, running off the screen here. 5 times 4 minus 4. So if I simplify that, 20 minus 4 is 16. And then CD is 2y, so plugging in 4 again, plus 8. So 2 times 4 is 8. 8 plus 8 is also 16. So BA is also congruent to CD. So with those being congruent as well, that's enough to say that these pairs are also congruent. So if two pairs of opposite sides are congruent, then ABCD is a parallelogram. And our reason, again, is because both pairs of opposite sides are congruent. All right, awesome. Let's look at a couple more here. And we're actually going to do this one first. Okay, so show that EFGH is a parallelogram for Z is 11 and W equals 4.5. So they're giving me 3 angles. These are opposite, so they should be congruent. And the consecutive angles should be supplementary. So we're going to plug in Z and W and see what we get for each one. So if I plug in here, so angle F, I'm plugging in 9 times D, so 9 times 11, plus 19. So when I do that, I get 99 plus 19, which is 118 degrees. So 118 is angle F. Angle G, I'm plugging in 4.5, so 14 times 4.5 minus 1. 14 times 4.5 is 63, and minus 1, it gives me 62. And last but not least, measure of angle H is 11z, so z again is 11, minus 3. 121 minus 3 is 118 degrees. So, since I only have 3 angles, we want to check the supplementary piece. If I also had this one here, I could make sure both pairs of opposite were congruent, but I don't have angle E. So I can check the consecutive or supplementary. So does 118 plus 62 equal 180? Yes. And it's happening with both pairs of consecutive angles. These two, F and G, and these two, G and H. Since both pairs are supplementary, that's enough to say that EFGH is a parallelogram. Because we'll say angle G is supplementary to both angle F and angle H. Okay, awesome. Last example here. It says use the definition of a parallelogram to show that this quadrilateral, KLMN, is a parallelogram. So definition, remember, says that the two pairs of opposite sides are parallel. So let's first graph these. So I've got K at negative 3, 0, L at negative 5, 7, M at 3, 5, and N at 5, negative 2. K, L, M, and N. And it does help here if you can use a ruler. Mine's not going to be perfectly straight. Try and make it look fairly good here. Okay, so I want to know, are both pairs of opposite sides parallel? So remember, we can know if lines are parallel on a graph by looking at their slopes. So let's look at the slope of LM, this top one. So remember, look at rise and run. So I would go down 2 and over 1, 2, 3, 4, 5, 6, 7, 8. So down 2 makes it negative 2 over 8, which we can simplify to negative 1/4. Okay, so if I check Kn, if it's also negative 1/4, then I can say those two sides are parallel. So Kn, rise and run, down 2 again, and over 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I'm going to get exactly the same slope. Which means LM is parallel to Kn. And you can, I wrote parallel there, sorry, that cut off a little bit. Okay, next one we're going to do is our two sides, LK. So here I would have to go down 1, 2, 3, 4, 5, 6, 7, 8. Oh, I went too far, sorry. Down 7 and over 2. So my slope is negative 7 over 2. And let's look at MN. Down 1, 2, 3, 4, 5, 6, 7, and over 2. So negative 7/2. Same slope again, so these are parallel. So KLMN is a parallelogram because both pairs of opposite sides are parallel. Alright guys, so using those conditions to determine whether or not a quadrilateral is a parallelogram. So make sure that you're pretty comfortable with properties and conditions moving forward. Thanks for watching.